I want to continue to review some algebra topics. This one is doing math with radicals, and in this case, I'm looking mainly at square roots, although the principles can apply to other roots. So let's start with just a quick example and explain the principles. So I'm going to take two very simple square roots. First here, we can add them or we can subtract them. We can multiply them or divide them. So the four basic functions of math. So what are the rules? How does this work when we have square roots? It's almost like when you first learned algebra, you learn to add and subtract like terms. And normally when we talked about like terms, we looked at the variables, and if the variables are identical, the same, including the exponents, of course, we could add these together. Now, in this case, we could not add 2x and 6x squared because these are not like terms. Turns out we could factor this, but we cannot add these terms together because they're not like terms. Well, in a sense, when you're trying to add or subtract radicals, the radicals have to be identical to add or subtract. If you look up here, square root of 2 plus square root of 6. These radicals are different. They're both square roots, but under the square root it's a 2 and a 6. And I can't simplify, so therefore there's nothing I can do with square root of 2 plus square root of 6. And in the same way, obviously, square root of 2 minus square root of 6, nothing I can do. Now, before we do the rest of these, let's just see an example of what we could do. If I had square root of 2 plus 4 square root of 2. So I have two different terms here. And because the radicals are the same, it's almost like you can treat it like you're adding x plus 4x, where you can think of the square root of 2 as like your variable x. So we know x plus 4x is 5x. If you really want to know how we add this, you can almost, you probably never think about this, but what you're really doing is you factor out an x and you get 1 plus 4, which is 5x. So up here, the same idea. Square root of 2 plus 4 square root of 2, it's like 1 times square root of 2 plus 4 times square root of 2. This is 5 square root of 2. If I have well, just for fun, 7 square root of 5 minus 2 square root of 5. Oh, I should have put 4 here. How about 3? 7 square root of 5 minus 2 square root of 5 plus square root of 3. 3 terms here. I want to combine or simplify as much as possible. The key is, I have to look at the square root, square root of 5, square root of 5, square root of 3. These I think of as sort of like terms. Since the square roots are identical, I can actually combine these. So it's like 7 minus 2. So this is 5 square root of 5 plus square root of 3. Now, if I look at these two terms, square root of 5, square root of 3, they're not identical. I can't do anything else. So here's the key principle. You're trying to add or subtract terms with radicals. If the radical is identical, exactly the same, then you can combine those terms. But if not, there's not a whole lot you can do. So to finish up here, nothing I can do here, nothing I can do here. Let me hold off on these, because what I want to do is show you one thing that sometimes can happen. You're given this, and our little rule we learned says, well, these square roots have to be identical. Square root of 2 plus square root of 8, they're not the same. Therefore, it looks like I cannot do anything. However, that's not actually true in this case, because what you have to remember to do is, before you make that determination, you have to go in and take each term and see if it can be simplified. Simplified meaning, can stuff be pulled out of the square root? In other words, square root of 2 cannot be simplified. But you know what? If you remember simplifying radicals, 8 is 4 times 2. Square root of 4 can come out as the 2. 8 is actually, square root of 8 is actually the same thing as 2 square root of 2. So I actually can simplify square root of 8 to 2 square root of 2. Remember, the idea of simplifying radicals is the number under the square root is as small as possible. So after I simplify square root of 8, lo and behold, actually, I can now actually add these terms because the radicals are identical. It's both square root of 2. This is like 1 plus 2, so this is 3 square root of 2. So the one thing you do have to realize is, when you're seeing if you can add or subtract radicals, you have to make sure each term is simplified. And then once you simplified each term, then you can decide whether they can be combined or not. And we'll do a few example problems in a few minutes that will cover this kind of thing. All right, so adding and subtracting. There's some things you have to pay attention for. Hopefully it's all pretty clear. What about when you multiply? Well, you know, it's almost like, if I can do an analogy, what happens when you learned to add and subtract fractions? Adding and subtracting fractions can be a little bit of a pain, especially if the denominators are different. What do we have to do for these problems? We had to find the common denominator and convert each fraction and go from there. However, if you recall, what do you have to do when you multiply two fractions? You don't have to do anything. You just multiply the numerators, multiply the denominators. That's why we love to multiply fractions. And in a sense, division's the same way, although I'm not going to go into it now. The point I'm making is, when you add or subtracted fractions, there was a lot more involved. When you multiplied fractions, it was great. The same idea can apply with these radicals. When you add or subtract them, you have to have identical radicals. When you multiply or divide, you do have to have the same root. So this is a square root and this is a square root. If you're multiplying two square roots, then you can just combine them under one square root. Now for this little example I made up, you know what? You would not leave this as your final answer. Why is that? Because this could be simplified, right? 4 times 3, this would be 2 square root of 3. But the key is when you're multiplying radicals, if the roots are the same, you could just multiply them, put them under the same square root, and you're pretty much done. So for example, what about square root of 2 times the cube root of 2, right? So this is a cube root. Here, there's a 2 here. This is a square root. What can I do here? Can't really do anything. You know, I multiply radicals if the roots are the same. So, and actually, this is something I should point out here now, which is an important math principle. I'm just doing this problem, but so if I made it square root of 2 times square root of 2, then since they're both square roots, I can multiply them under one square root, square root of 4, which is 2. Now here's just a sidelight that becomes important in math. Since this is my example, square root of 2 times square root of 2, you know, I could rewrite that. Isn't this the same thing? Square root of 2 squared would be a square root of 2 times square root of 2. This becomes very important in the world of math because there are so many times in math where it's like the square root and the square are sort of like inverse functions or opposites. And in this case, whenever you see something like this, it's like they sort of cancel out and you're just left with what's under the radical. That's like if I have the cube root of 5, but then I cube it, it's like cubing and the cube root, so it'll cancel each other out and you're simply left with what's under the radical. Now, while I'm doing this, just for fun, although you may already know this, just one more trip down this rabbit trail. I can rewrite this. What's interesting is up here, I have cube root of 5, and I take the whole thing and I cube it. So here's cube root of 5 again. But instead of cubing it and putting the exponent outside, I could also put the exponent on the inside. These are identical. It's almost like two different ways to write the same thing. When I look at this, I'm sort of cubing the cube root. They sort of cancel out, you get the 5. Here, I'm taking the cube root of something cubed. They sort of cancel out. It's still 5. All right, that was a rabbit hole. Maybe you already knew that, but this is use this a lot in algebra. So where were we? We were learning how to multiply radicals. So the key is if the roots are the same, you can go and combine them under 1. How about dividing? This is a fraction, but a fraction is very division. Same principle as multiplying. If you're dividing two radicals and their roots the same, you can just combine them under one radical. In this case, 6 divided by 2 is 3, so this would end up being Now, here's one interesting, because in a few minutes, we're going to do some examples where we go the opposite way. Sometimes you'll be given a fraction under a radical. In order to solve that problem, a lot of times you actually want to split up the fraction into two separate radicals. So for instance, just do a quick example. How about square root of 5/4? Just so you know, when in the world of math, we always have to simplify radicals. Like normally in the world of math, they really don't want you to leave this as an answer. They don't like to leave fractions under radicals. One of the ways we can simplify something like this, you break it up into two separate square roots. So in this case, we could say square root of 5, square root of 4 is 2. Now this is an acceptable answer in the world of math. Because the main thing in the world of math, they don't like fractions under radicals, and they don't like radicals in the denominator. So just for fun, what if we had this? In order to simplify, I need to simplify this. This is not really in a form they want me to leave it in. So normally, one of the ways you can simplify it is you go and break it up into separate square roots. Now the problem is the square root of 6 in the bottom. That's what they don't like. Now here, this becomes a problem of rationalizing the denominator, which is another topic. But if you remember how to rationalize the denominator, when you have a square root in the denominator, you just multiply the denominator by the identical radical. Of course, I have to do the top and the bottom, right? So this is, I don't want to do a lesson on rationalizing the denominator. This is how you do it. So then you end up with, in the bottom, square root of 6 times square root of 6 is 6. Now look at here at the top, square root of 5 times square root of 6. Since those are identical, same roots, and I'm multiplying, I would call it square root of 30 over 6. All right, so quick review, then we'll do a few examples. Adding, subtracting radicals. Radicals have to be identical, which means the roots and the stuff under the radical has to be exactly the same. If that's true, then we can't add or subtract them. Multiplying, dividing, if the roots are the same, you can combine them, you can multiply them, or you can divide them. If the roots are not the same, you can't do anything. So I made up some examples of some of these principles. So how about this one? Square root of 5 plus square root of 20 plus square root of 45. So I'm trying to add these three square roots. First glance, they're not identical. I can't do anything, but remember, you need to simplify all these square roots before we decide they can't be combined. Square root of 5 is already simplified. 20, right, is 4 times 5. So the square root of 4 comes out as a 2. So square root of 20 is the same thing as 2 square root of 5. 45 is 5 times 9. The square root of 9 can come out as a 3. So by the time I simplify each term individually, I now look and I have square root of 5, square root of 5, square root of 5. So you know what? It's like 1 plus 2 plus 3. Turns out we were able to combine them once we simplified each square root. One more like this. Four terms here, all square roots. Once again, first glance, none of these square roots are the same, but of course I need to see if they can be simplified. This is 4 times 3, so a 2 can come out. So this simplifies to 2 square root of 3. Square root of 2 is already simplified. Square root of 3 is already simplified. 32 is like 16 times 2. 16 comes out as a 4. So now I have simplified all 4 terms. Now can I combine these? Well, it's 4 terms. Square root of 3, square root of 2, square root of 3, square root of 2. Actually, 2 of these terms have a square root of 3. So 2 square root of 3 minus square root of 3. I can combine those. And that leaves me a square root of 3. Square root of 2 minus 4 square root of 2. These radicals are identical. So this is really 1 minus 4. So I can actually simplify it down to just 2 terms. Actually, I think everything we've done so far is suspend with numbers, but of course, we should actually look at variables. But the same principles apply. For example, what do you think about if I was trying to add square root of x plus square root of y? Well, these square roots are not identical, so there's really nothing I can do. How about if I was multiplying square root of x times square root of y? Well, since the roots are the same, I could actually multiply them. So that means, say if you had a problem like this, 2 times 2xy times square root of 5 5x. Since these 2 square roots, those are both square roots and they're multiplied, just to make it clear, I won't even skip any steps. So the 2xy times 5x, of course the 2 is out front. So now I have 10 x squared y. Of course, this is not really simplified because you know what? The x squared can come out as an x. So you would have that. How about in a sense we're dividing here, but I write it as a fraction. Can I do anything here? Yeah, if I wanted to. I could put them under the same square root. What's actually more common is sometimes you start out with the fraction inside a square root. And what you really need to do to simplify it is a lot of times you want to split this up, and then it makes it very obvious what to do. Because square root of 100 is 10. So the square root of x over 100 is really a square root of x over 10. This is the appropriate answer. So here's a problem with both numbers and variables. Actually, before I do this one, let me do one that's a little simpler just to make the point. How about what if you're trying to simplify this? Two different terms. I have square roots. I can only subtract these if the radicals are identical. Square root of 2xy, square root of 2xy. This is like 2 minus 1. I can actually combine these into square root of 2xy. Down here, 3 terms, square roots. First glance, none of them are identical, but I need to simplify. Now in this case, nothing to do with the x, but I can simplify the numbers. For instance, 18 is 9 times 2. So square root of 18x becomes 3 square root of 2x. 98 is 49 times 2. Square root of 49 is 7. 200 is 2 times 100, so 100 comes out as a 10. So lo and behold, after I simplify each of the radicals, I have square root of 2x, square root of 2x, square root of 2x. I can actually combine all these. So 3 plus 7 is like 10 square root of 2x minus 10 square root of 2x. You might have never known it from the start, but when you add and subtract all these, it's actually 0. All right, so once again, a quick review on doing math with radicals, and in this case, almost all my examples were square roots, but the principle applies to other roots also.